Good morning to all. I, Ashish Singh, welcome all the participants in another session of this FDP. It's a privilege to have Dr. Ftwi as an expert speaker with us in the current session. Dr. Ftwi is an academician and researcher and currently working as an assistant professor in the Department of Mechanical and Industrial Engineering, College of Engineering in Sultan Qaboos University at Sultanate of Oman. Before he joined SQU, he has served as a senior lecturer in College of Engineering and research fellow at the Automotive Engineering Center, University Malaysia, Pahang, Malaysia from 2014 to 2020. He received his PhD degree from Department of Mechanical Engineering, University Technology Petronas, Malaysia in January 2014. He received his Master of Engineering degree from Mechanical and Production Engineering Department, Delhi College of Engineering, Delhi University, India in 2005. He received his BSc degree honors from Mechanical Engineering Department, Faculty of Technology, Addis Ababa University, Ethiopia in 2001. He has served as a lecturer from 2005 to 2009 and later as assistant professor from 2009 to 2010 in Mechanical Engineering Department, McGill University. During his service at McGill University, he has assumed different academic and administrative posts for the department and the university. He has published more than 60 articles in international scholarly journals and conferences. He has also supervised 2 PhD, 2 master theses by research, 7 master theses in mixed mode, 1 master's by coursework dissertation, 48 undergraduate final year projects, and 4 final year diploma projects. His area of specialization is internal combustion engines, thermofluids, and energy. His research interests are in the field of internal combustion engine, combustion, modeling, and simulation, optical diagnostic applied to combustion and flow, thermofluids, renewable energy, energy resource assessment, and automotive engineering. He is also a chartered engineer and member of Institution of Mechanical Engineers, UK. Besides, he is also a member of editorial board of American Journal of Energy Engineering, International Journal of Renewable and Sustainable Energies, and Journal of Energy and Natural Resources since 2014. Since January 2015, he is an associate editor-in-chief for the Journal of Mechanical Engineering and Sciences. I welcome you, sir, for your expert talk, and over to you, sir, for the informative session.
Thank you, sir, for the wonderful introduction. Can you hear me?
Yes, sir.
Okay, thank you very much. I really, I'm honored to be with you all. So, thank you for the hostess for inviting me to participate in this session. Yeah, I will just present my slides first. Yeah,
yes,
just,
sir, it is visible.
All right, okay. I will ask apologies again, just if there is any inconvenience with the technical issues, because I have not used this mode. I think this is Cisco, right?
Sir,
Yeah,
in spite of so many difficulties, if you are with us, it's privilege for us.
Yes, I'm really happy to. But previously I used to use Google Meet and that of Zoom. This is the first time I'm using this Cisco. Yeah, so I hope it will be all right. I will manage to handle it.
Yes, sir, you
Okay.
can, sir. Okay, thank you,
Yeah.
sir.
Just this is the presentation slide I have. At the battery thermal management. And my name, as you already introduced, my name is Yohaness Hagos. So just let me give you a brief about my institution. And Sir has already wonderfully introduced about myself, so I will not repeat anything about myself. But my institution, currently I'm in SQU, Sultan Qaboos University. And it is established in 1986, and it was commenced with 5 colleges, and engineering is one of the first colleges institutionalized in that year. And this university is one of the best universities in the Gulf countries, and we have, like as you can see, a total of around 17,500 students. This data is in fact 2017 data, but we have close to this range students at this moment as well. So this is with regard to the introduction of my institution. Then I would like to thank the National Institute of Technology, Srinagar, especially Dr. Harbir Singh Pali, for inviting me to participate in this session. Really, I'm happy to be a member of this scholar team, and I hope we'll have a good engagement. And as I said, this is a two-way. It is not like a lecture, rather it is a conversation. So I have lots of things to learn. My specialty in this specific topic is even very narrow. Especially my area of research in this topic is on the passive mode of thermal management system. So especially I will provide you more details with regard to this passive mode of thermal management system, especially with phase change material. But overall, I will try to give you some highlights on the research aspects of the overall battery thermal management system. So to begin with, just first thing, you might have discussed this thing over the period of these training sessions. But in order to have a clear understanding, it would be interesting if we can discuss somehow on the opinions we have, whether this electric and hybrid vehicle is a solution for our future transportation. Do we think in that way or otherwise? And I have just created one platform, which is we call it Padlet. And if possible, please write your name. And again, try to write your opinion so that it will help us to understand what is the understanding we have on what is the perception we have about the future of these electric and hybrid vehicles, and how we think whether it is a viable solution for our future transportation aspects. So I will just copy and paste this link in the chat, and as a result, you can interact within that chat.
So can I put this link in the chat box?
Yeah, I
Have you
already
any?
put it. Yeah, I
Yes,
already
yes,
put
yes.
it. You can see me, I'm struggling with it, right?
Yes, I'm putting. Okay.
All right, okay.
It is available now in chat box, sir.
Yes, okay. So if we go to Then if you write something, we will be able to see what you write on this Padlet platform. So everyone can participate with it, and I just give some opinion. First, if you agree, then how, and if you don't agree, why not? Okay. You know, the argument in here, what we have is many people think that the automotive industry is receiving more attention, just unfairly being targeted as compared to the other industries. And some people are saying that the EV by itself is more pollutant than that of the internal combustion engine. Okay, and some people are saying the battery and its environmental impact, especially the production of the battery itself, then the disposal of the battery itself is worst. Their suggestion that way. On the other hand, because the EV, especially for the power conversion efficiency is high, and the power to wheel ratio is very big, and as a result, the carbon emissions will be too low, and they consider it as a viable solution for the future transport. So that's why I would like to hear the opinion from your side on which side we place ourselves, and how do you see especially the arguments? Yeah. Mm. Yeah, we have more participants. All right. Okay, let's proceed. We already took 5 minutes. So let me go to my my outline then. Okay. So I'm back to the slide. All right. So as far as the outline is concerned, just the first thing, as we have seen from the previous slide, we want to see what are the major concerns. And I feel that you might have seen the data which I am presenting now in another sessions, but still it is good to look at from where I see it, and so that we will have an agreed understanding about the background and about the issues we have at hand. So I feel there might be some repetition here, and because I prepared this slide just as part of the content in my presentation everywhere. So first, what I would look at is the transportation, how it is the scenario itself, and the energy aspect of the transportation and its scenario itself, and the emission aspect of the transportation and its scenario. Then what sort of mitigation aspects we have, and why we are looking on the electrical vehicles aspect. And then we proceed with that of the electrical vehicles and its battery system. So as far as the transportation is concerned, as you can see here, in both aspects, like the passenger traffic as well as that of the freight, global freight, is going to be exponentially increasing. Okay, so as you can see over here, by 2030, the annual passenger traffic will be increasing by 50%. And whereas the global flight volume will be increasing by 70%. And we are expecting by 2030, the current automotive vehicles figure will be double, which will be adding additional 1.2 billion cars. And here, just what I always compare things is, we have by 2030, we'll be reaching around 2.4 billion cars. And out of these 2.4 billion cars, the first 1 billion cars, it took us over 100 years to reach this 1 billion mark. Whereas the next 1 billion mark is to be reached within 10 years only. So imagine if we are looking for the third 1 billion, in how many years we are going to reach that. So the demand is increasing by skyrocketing. It is unimaginable. So that's why it is becoming a big burden on the supply of the energy itself. So especially this increase is more exaggerated on those developing countries. And those developing countries, their main issue is because of the development, one aspect. In these developing countries, there are many people moving from the poverty to the middle class. So when they move from the poverty to the middle class, their demand for the personal transportation, their demand for usage of air transport and so on increases. And as a result, the amount of energy requirement is also increasing by that. So as you can see again, the increment, still the dominant energy source for the transportation sector will be that of liquid fuel, as you can see over here. So until 2040, still the demand for liquid fuel will be increasing, whereas starting from 2040, that demand will be stabilized because the other source of energy will be starting to take over as well. So the challenge here is, with that of the liquid fuels or the petroleum-based fuels, the biggest problem is that of it is carbon intensive. So when we are burning this, then we are producing more carbon dioxide. So the carbon dioxide part is the most critical aspect in here. As far as the data we have for the 2018 is concerned, over 24% of the CO2 emissions comes from that of the transportation, which is we have 8 billion tons of CO2 emissions in 2018. Out of it, 24% is that of driven from that of transportation. And again, from this transportation, over 74.5% is coming from that of road transport, which is from automotive. So that's why this electric vehicle is very vital in addressing that of the CO2 emissions. So this is how we are associating that of the electric vehicles with that of the CO2 emissions. So 24% of the total CO2 emission is coming from transportation. Again, 74.5% of the total CO2 emission of the transportation is coming from that of the road, which is from automotive vehicles, which includes that of motorbike, cars, buses, taxis, trucks, and lorries. And again, this figure in 2050s, it will be a different scenario. We'll be having around 12 million, 12 gigatons of CO2 equivalent per year. So, which is very huge as well. So again, we shouldn't overlook the other source of CO2 emissions in here. And as I mentioned previously in my previous slide, some people are blaming the perspective or the narrative we have, where they are feeling that the automotive is unfairly being targeted because the other industries are not getting the attention what the automotive industry or the transportation sector is receiving. So again, you can look at the research findings and the research papers in this aspect, and you can compare how the narrative itself, because some people look at why we don't target the meat industry, because the meat industry is again another source of huge CO2 emissions, and the meat industry is not receiving equal attention that like the automotive industry, even though its potential is too high equally. So this is some perspectives we have, and we can look at from the different aspects, but still we cannot hide the available data on the transportation sector. So the solution which we are targeting is that of the industry. And again, we shouldn't be misled by the findings we have from the 2020 and 2021 about the emissions, especially the transportation sector emissions, because the COVID has impacted the trend, and as a result, we cannot use as a long-term evidence or as a long-term data for our analysis. So mitigation aspects, we have two ways of mitigation. One is the energy intensity reduction, especially with the efficiency aspect of it. And the other one is fuel carbon intensity reduction. Well, still we use the fuel, but we can remove the carbon content, or we can minimize, especially if we move towards that of the hydrogen, because the combustion of hydrogen will not generate that of carbon dioxide, and we can move towards that. However, still we have a huge limitation on that aspect. So the viable solution we have at the moment is that of the electric vehicles and that of electric and hybrid vehicles. So With that mitigation aspect, in fact, yes, the greenhouse gas emissions will be hugely minimized. However, still we have the challenge, and the bottleneck in that aspect is that of the battery and its associated technologies, and the infrastructure which requires, especially for the charging. So here are some of the mitigation planning and strategies where countries are driving or moving ahead. And some countries, they are targeting to ban that of the sale of the internal combustion engine vehicles in 2030. Some countries, they target 2040 is the visible option. And among this, India at some point has targeted 2030 is a viable option. However, we can look at how the readiness and that of the preparedness regarding this aspect. How, when we look at the readiness, we can look at from the aspects of like the diversity of the energy sources. What are the major sources of electricity in India? Is it well diversified? And especially this electric vehicle is more suitable when we are generating the electricity from renewable sources. So how is India's mix of the renewable energy in the electricity sector? We can look from that aspect. The other thing is the population growth rate. If you see on the advanced countries like the OECD countries, their energy demand is balanced because their population growth is also well balanced. Whereas on the developing countries like the African countries, the demand of the electricity is growing because of the huge population growth. Not only on the development aspect, but on the population growth. So while you have huge population growth, which demands huge energy growth, so can we substantiate the requirement of electricity for the automotive industry is another aspect. And we can look from the energy demand growth itself, because the energy demand growth is affected by the population growth, by the economic growth, and the GDP growth, and the distribution itself. How evenly distributed is the electricity within the country? Geographic aspect, climatic aspect, and rural to city distribution, and energy consumption per capita. And if the energy consumption, the current energy consumption per capita is very small, so for sure it will increase because the demand will be increasing, and as a result, this can be also another indicator. And from the technology readiness, how is the knowledge capital regarding the EV technologies itself? How is the manufacturing plants available within the country? How is the country striding towards the independence, technology independence with regard to this EV? And how about the installations of the charging system and so on? These are some of the factors which influence the preparedness of countries towards that of the complete shifting into EV. So I have another exercise. Again, I will copy and paste the link in the chat. This will help us to just list out the factors in the Indian context and again rating them based on their impact, so that we will have some highlight or some understanding on the scenarios on the shift from that of internal combustion intensive vehicles towards the EV intensive vehicles. So I take you back to the chart. Okay, so this is the second activity we have. So again, in this activity, what we have is, let me take you to yeah. So this is the activity we have. So list factors influencing the future directions of EV in India and select the top 4 and rank them. That is the activity we have. Then especially I just want to see the battery technology and the associated infrastructures availability, how it's ranked, so that we will move towards the battery. Is the activity clear or not? I don't see participants. So the activity is on the preparedness of India towards the future directions of the EV. What are the most influencing factors? Just we want to select the top factors. It can be from the few lists I have as well. You can choose as well, or your own. Okay, thank you. Even though it is anonymous, somebody has already provide us 4 factors: charging infrastructure, battery technology, affordability, and adaptability of people to EV. Wonderful. So I'm assuming that your listing is based on priority, right? Based on ranking. So yeah, most of you are concerned the charging stations and the charging infrastructure. And cost is being listed in at least, in at least 3 of the respondents. Yeah. Mm-hmm. How about from a policy aspect? From policy aspect, what I observed is in India, the EV related policy is 2 types of policy. We have the national policy as well as we have also statewide policies. So again, evaluating from the policy aspect, how the policies are enablers for the intended purpose. This is also another main factor. Okay, so let's go to our next slide then. Thank you for those of you who participated on this activity. Yeah. All right. So even though, as we have seen from the previous slides, electric and hybrid vehicles is being taken as one of the mitigation option for this environmental issue. The trend and the progress towards this target is quite slow. As you can see, the data we have for 2019 alone, only 7.2 million cars are available on the road. Okay, and as far as the charging stations is concerned, worldwide, again, we have only 7.3 million chargers worldwide. So this is dragging from the expectation. So we are long way to go to reach what we are aspiring to be. As far as India is concerned, especially in the last 4 or 5 years, the progress is good, and by 2026 we will be having the market penetration as a result. USD 47 billion market will be for the electric vehicle in India. So that will be somehow a promising aspect as compared to the market share where it is 5 billion in 2020. So as far as the electric and hybrid vehicle is concerned, well, it is being promoted because the power to wheel ratio is higher as compared to that of the internal combustion engine, where we can convert the power provided to wheel up to 82%. This is higher as compared to that of the internal combustion engine, where it is 12 to 30%. And that is the main benefit in here. However, still with this aspect, we have an energy loss in charging, which is close to 16%. Again, this energy loss in charging is heavily dependent upon the operation temperature, which we are going to discuss later on. So we have a big gap which we can play along, and that's why we are focusing on the battery system in this aspect. So the battery, well, for the automotive, lithium ion is taking the lead because for the automotive, it is a mobile application. As a result, we demand something very compact, which has higher energy density and which can be charged very fast, and its lifespan should have to be big. Of course, the cost should have to be also less, and the depth of discharge should have to be higher, and its efficiency should have to be higher. And with this aspect, the lithium ion battery is leading in many of the aspects. Only the cost is the issue, and cost-wise as well, even though this is a bit older data we have, cost-wise, the lithium-ion battery is heavily reducing, and it is becoming very competitive to that of the lead-acid battery. As far as the technology is concerned, again, I will not go into the details of the technology because somebody else can say better with this aspect. However, the chemistry is heavily related with that of the heat generation in the battery. So having a proper understanding about the chemistry will help us to understand the forms of heat generation and the forms of removal of the heat from the battery itself. So we need to understand the chemistry of the cell. We need to understand the arrangement of the, sorry. Okay. Yeah, I proceed. So, as I said, I'm not going to go into the details of the battery chemistry. I feel that somebody else can say a lot about it. So, but my concern here is if we completely understand about the battery chemistry, then we'll have a clear understanding about the heat generation mechanisms. And further, we'll be having an understanding of how the heat removal process will be. So in anyhow, we have the cathode. Mainly it is the house of the active material, which is the lithium oxide, and we have the anode, where the ions will be intercalated within the anode, and we have the electrolyte, which will be the medium to transport the ions, and we have a separator. So each of these components have their own generation aspects, heat generation aspects. So I will not go into the details of the charging and discharging process. However, the heat generation in the lithium-ion battery in the cell itself, we have internal resistance heat generation as well as entropy change heat generation. And these all are influenced by the temperature and the charging method or discharging method, as well as the direction of the current itself. Okay, there are many mechanisms of estimating the amount of heat generated, and in the literature you will find lots of efforts, and those efforts are categorized into the use of test batteries experimentally. Mostly they are using this calorific method. And we have calculation based, like the calculation of heat generation factors, the simple estimation method, detailed estimation method of the over voltage, and that of the heat generation due to entropy change and the estimation of the entropy change. And as far as the cell types are concerned, we have different types of cells, and the most common ones for the automotive industries are the polymer, as well as that of the cylindrical cells. And these cells will be arranged in module form. Then the modules are packed in a pack. And the arrangements of the pack depends upon the chemistry, the cell type, the desired voltage and the capacity, and the dimensional space constraint we have, especially for the mobile application. The space is the most dominant factor in the arrangement. And the amount of heat generation is also influenced by the available space we have. So with this, we have different forms of pack configurations. We have the linear or F-type, we have the multi-row cells, we have the nested type cells. Nested type, we have two types of nested type. We have the custom nested, we have F-center nested. We have the circular type cells, 3-cell, 4-cell. We have pentagon cell, we have hexagon cell. We have the linear or L-type cells as well. So these are the configurations. And again, the configurations depend upon the type of cooling system we are employing. So in here, as a nutshell, our interest is, because we have seen that the lithium-based battery is the most dominant in the automotive for the electric and hybrid vehicles. But this lithium-based relies more on the cobalt, manganese, nickel, and graphite. And these materials are rare earth materials, and they are available in some specific locations on the globe. And price-wise, as I mentioned previously, it is reducing. Currently, we have reached up to $135 per kilowatt hour of the battery cell cost, which is huge reduction as compared to the price which was in 2010. So the trend is good. It is believed we will be reaching around price of 50 USD by the year of 2030. And another issue is the high battery charging loss, which is a center of focus at the moment, where up to 16% is being lost, and it should have to be reduced. Another issue is where the lithium-ion battery is lagging from that of acid-based battery on the recycling basis. So recycling will help to reduce the dependence on the rare earth materials. However, the recycling issue is currently lagging, and as a result, its environmental impact is also under question in this aspect. Besides, we are also interested on the high energy density battery, because for mobile application, we demand compact and lightweight materials so that we get enough space for occupants, and also we minimize the inertia for the efficiency of the vehicle. And fast charging is another factor. So as far as the construction is concerned, in order to have the required amount of power, the battery should have to be arranged in thousands of cells, should have to be packed together. And the packaging is those cells should have to be clustered in modules first, then the modules should have to be further packed in packs. So those packs are configured in different configurations, and it should have to be fitted within the available space of the vehicle. So this is the most limiting factor as far as the vehicle is concerned. Unlike that of the solar industry or the power generation, where we have enough space in stationary applications, whereas in the automotive industries, the space availability is the most limiting factor we have. When the space becomes a factor, we need to squeeze it within the available space, and as a result, the dissipation of the heat generated will be a big issue. So temperature will increase with no cooling. The temperature of the battery may go beyond 55 degrees centigrade. And this temperature will be quite damaging for the battery itself. And beside that of the rising in temperature, fluctuation of the temperature is another factor which is also critical for the battery life. So that's why the battery thermal management is more critical for the battery performance and its overall life cycle. If you see this graph, the retentive capacity of the battery itself is heavily dependent upon the operation temperature. The performance of the battery is well served when it is operating within the range of temperatures from 20 to 40 degrees centigrade. Some researchers narrow this gap even from 15 to 35 degrees centigrade. And on the safe side of the battery, even lithium cells are more preferred or more optimally operating when the temperature is below 45 degrees centigrade. Beyond that, it will be degrading quickly and its lifetime will be shortened. And the cell-to-cell temperature variation should not also be beyond 5 degrees centigrade. Otherwise, there will be imbalance, and that imbalance will generate further higher temperature, which will lead the quicker degradation of the battery. So that's why we need a battery management system. So usually the battery management system is a big monitoring system, which also overlooks the other components, like besides that of the temperature monitoring, it also includes that of cell overcharging and activation of the protection when the cell is overcharged. Again, it monitors when the cell is over discharged, and it notifies that of the operator when the cell is discharged, over discharged. And it also plays on the cell balance for steering charging. Temperature monitoring is another factor or another component of that of the battery management system. Remaining state of the charge determination, and also counting of the charge and discharge cycle. And accordingly, we can estimate the life cycle based on that. And especially as far as hybrid vehicle is concerned, and this BMS system is coupled with that of the engine ECU, and it will be integrated as a vehicle management system. However, our focus here is only that of the BTMS, which is the battery thermal management system, which is one module, one component of that of the BMS system. As far as the battery thermal management system is concerned, again, the operation temperature will affect that of the battery chemistry, the charging, discharging efficiency, the life cycle or the lifespan of the battery, the charge acceptance, and that of the safety itself. So the BTMS is just, it is beyond a simple heat removal process. It is a monitoring and regulation mechanism, because the temperature should have to be also stabilized. It is not only simple removal of heat, but it is stabilization of the temperature so that there is no fluctuation and it is not going beyond the range of operation. So we have certain requirements where a BTMS system should have to fulfill. One is it should have to be compact. Space limitation is the biggest factor we have. So it should have to be fitted within the available space. Another factor we have is weight. Of course, with an increase in inertia, again, we are playing with the efficiency of the vehicle itself. Easily packaged, reliable, serviceable, lower cost, low parasitic power. It shouldn't consume huge power in order to do its purpose. Optimum temperature range. Small or no temperature fluctuation at all. Safety as well as component compatibility are some of the factors. We can still add more factors, especially with different types of BTMS systems. We have added requirements as well, especially when we are coming towards refrigerated BTMS system. Toxicity, because there is a chance of getting exposed with that of the refrigerant. So the type of the refrigerant we are going to use for that should have to be another factor. Okay. So BTMS types are categorized into two major groups: passive and forced BTMS systems. On the passive side, we have a natural air convection and we have a PCM. PCM stands for phase change material. Okay. So I have indicated some of the automotive vehicles or the technologies being employed, like the natural air convection. We have the Audi TT hybrid vehicle. We have the Nissan Leaf. For the PCM, we have All Cell. It is a battery technology manufacturer. Mostly those batteries are being utilized for bike and scooters. Cabin air ventilation, mostly employed by Ford and Honda. The technology is developed by Ford and Honda. We have air conditioned air or conditioned air to battery. And this one is cruise and inside. Ambient cooled liquid. And we have also refrigerated liquid. When we say refrigerated liquid, we have two types. One is we have a heat transfer fluid. Another one is we have direct the refrigerant being employed as a cooling liquid. As far as the natural air convection, as you can see from the schematics, we have two types. Again, some people classify this natural air convection into two, as a passive and as a forced. The basis for the classification in this aspect is when we say natural air convection, the air is not being cooled or heated by any form of refrigeration process. Yeah, sorry, is there any question?
I think there is no question, sir.
All right. Okay. Thank you very
It's
much.
clear, sir.
So I'm not also looking at the chat. Hopefully later on, I will be addressing some of the issues.
Sir, yes, sir.
All right. Okay. Yeah.
Ashish, please look. Any mic is open.
Okay. Yeah. Yeah. May I proceed? Okay. So yeah, sorry, there is some disturbance. All right. Okay. I think now.
Yes, Dr. P. Shiva Prumal. Is there any question, sir? I think
We can
it's
proceed.
okay, sir.
Okay.
Please start.
Yeah. Okay. Thank you very much. Yeah. So as far as this natural air convection, as I mentioned, some people they classify further into natural and forced, or passive and forced. This is just based on the arrangement of the fan. If the fan is being used before the battery, or the fan is arranged before the battery, they claim that it is a forced BTMS, whereas when the fan is arranged at the exhaust side, then they consider it as a natural convection. Some of them, this arrangement totally, they consider it as a natural air convection, as a passive, because it doesn't have any refrigeration or any separate cooling loop attached to it. So they consider it as, it is still as a natural or passive air cooling system. Let's look at, so the classification can be another issue where you can enrich it further from different literatures, but what are the advantages and disadvantages from this aspect? As you can see, this mechanism is quite simple. It is cheaper because no major components in here. It is lightweight. The influencing factors for the weight is, one, the added components. Second is the medium itself. The medium, the cooling medium itself. In this case, because it is air, so there is no medium which is permanently being stored in the vehicle. As a result, the weight will not be affected. Whereas if you consider like a liquid, so the liquid should have to be circulating, and as a result, it should have to be permanently stored within. So it will be an added weight within. All right. So in this case, it is a lightweight, and of course, the maintenance is easy. Furthermore, leakage issue and associated electric short concerns are nil within this kind of technology. Besides that, we don't have any cooling loop, so we don't have any issue as far as additional components is concerned. On the disadvantage side, the heat transport capacity is too low because we are using air, so the heat transfer is not effective. And we will be having high parasitic power because we have a blower. Then in order to make it effective, we need to discharge more air. And as a result, the power requirement will be high. Besides this, the vehicle will be too noisy because we have a blower. constantly operating, and this is another factor as well. And the temperature control is very poor in this aspect, and the variation is high, and of course it is going to be dangerous for the battery. With this technology, we have this Volkswagen EV racing car, which was designed with this technology, and it has operated quite good during its racing. Another type, which is a purely passive mode of BTMS system, is the phase change material. So again, I believe some of you might not have a detailed understanding about the operation of phase change material. So I just added these schematics, as you can see over here. So the phase change material is a material which works under the latent heat operation. Okay, so when this material is changing its phase, okay, let me just correct my pointer so that I can easily write on my screen. Okay, so as you can see over here, we have a solid phase change material. When its temperature reaches its melting temperature, so the material will melt and the temperature remains constant. All right, so it is absorbing heat while the temperature remains constant. So that amount of heat absorbed will be a latent heat. Then once it is completely changed into liquid form, then its temperature can increase. So when we are operating the phase change material at its melting temperature range, then it will absorb heat while the temperature remains constant. So it stabilizes its temperature. So as you can see on this cube, when we are designing an envelope, which is a phase change material envelope, and if we insert the cells within, so when the temperature of the cells increases, then heat will be transferred into the phase change material. And if the temperature of the phase change the temperature of the cells is higher than that of the melting temperature of the phase change material, the phase change material will start to melt. So it will keep absorbing the heat until the phase change material becomes liquid, completely liquid. Over this operation condition, the temperature of the cells remains constant. So since the phase change material is constantly placed on it, so we don't have any additional components to be attached. That's why we call it a passive. We don't have any additional power to be added because we are not going to pump it, we are not going to recirculate it or so. So this is the operation mechanism, and it is widely receiving attention in the automotive battery for the EV as well as for hybrid vehicles. So what are the advantages with this aspect? We have high energy density. Unlike that of the air or liquid, this phase change material is operating within the change of phases, and as a result, it can absorb huge amount of heat while it's not changing its volume or it's not changing its dimension. High compactness, no moving parts, and as a result, it's quite simple. No parasitic energy or power, low maintenance cost, easy to use, constant temperature, less fluctuation. The disadvantage we have is because we have different types of phase change materials, the compatibility of these phase change materials with that of the components of the battery cells as well as the packs is not thoroughly studied. Safety-wise during drive, safety-wise during parking, safety-wise during long storage, safety-wise during accidents has not thoroughly studied and investigated. Leakage is one of the issue and one of the concern, because we are enveloping that of the cells, and if there is any contact and if there is any ignition, so especially when the phase change materials are hydrocarbon based phase change materials, there will be a tendency of electricity or electric spark as well as that of fire. Well, there will be an added weight, especially this added weight will depend upon the type of the phase change material we are employing. So still there are research undergoing to find lightweight materials as a phase change material. So it is a huge interest. As I mentioned, there are lots of research. And again, I can discuss more, especially during the question and answer later on, if you have any question related to this. Another type of BTMS is the cabin air ventilation. This type of technology, again, it was first being used by Honda and Ford. So in here, what we have is, we have an outside air coming in and pass through the HVAC system, and then it goes to the cabin so that it will be used as a comfort. Once it serves as a comfort air, then it passes as an exhaust towards that of the battery pack. So it will serve as a cooling, then it will be going as an exhaust. So this is the mechanism. So you can recirculate it within the battery pack, but you can you cannot return back it into the cabin itself. So again, this has its own advantage and disadvantage. The advantage we have is it doesn't require any separate cooling loop, because we are using the air which is utilized as a cooling for the cabin. Then it will be collected from the cabin and pumped into the battery pack. So it is sharing that of the cooling system and other components of the aircon system or that of the HVAC system of the vehicle. And this also is an advantage because we are not recirculating that of the cabin air, and as a result, it is a mechanism to remove toxic gas. And its cost is also minimum. However, from the disadvantage perspective, when we are employing the air from the cabin, the air will be humidified air, and as a result, there is high moisture content. Therefore, when we are bringing this air into that of the battery pack, so there will be leakage concern. And as a result, there will be electric short and related issues as a concern. The other thing is, again, we are using air, and even if we are still using a cold air, its effectiveness and its control of the temperature is poor because of the low heat transport capacity of the air. Then we have a slight modification of this by the use of direct air conditioned air into the battery. So that means from the air conditioning system or from the HVAC system, we'll be having two branches. One is towards that of the cabin, and one is directly to the battery. Okay? So this is claimed to have better thermal stability and, of course, no compatibility issue, because the air is dry air just directly going into that of the battery, so the moisture content can be regulated by the HVAC system. The disadvantage is, again, we are sharing that of the HVAC system, even though we have a separate route, but still we are sharing the same facility. So there will be a sacrifice on the comfort of the cabin. Of course, there is high parasitic power. There is some complication and associated higher maintenance cost, and of course the system will be more expensive. And another type we have is the ambient cooled liquid. So in this aspect, we have a liquid permanently circulated. So this permanently circulating liquid will be cooled. It is typically the same to that of the engine coolant we have in the internal combustion engine. So whether a coolant, whether a water, whether a dielectric liquid, or we have bioglycol, different types of liquids are there, or some other heat transfer fluids for that matter. This fluid will be recirculating. However, this liquid will not be further treated, just it will be cooled by an ambient air. So we will be having a heat exchanger over here, where the liquid will be cooled by that of the fresh air from the atmosphere. So the only parasitic power we have in here is that of the power for the pumping. So the power for the pumping is very low, and as a result, we have low parasitic power. So we can get a uniform battery pack temperature. Again, the liquid in the batteries, it can be a direct exposure where the battery can be an immersion within the liquid tank, or it can be as a cooling jacket. So the mechanism can be two different types. And both of the technologies are available, and their effectiveness has been thoroughly investigated in different researchers. So in both of the cases, we have a uniform battery pack temperature, higher heat transport capacity. We have compact design because we are employing liquid. So it has low volume, better temperature control. I say better because still we are using a natural air for a cooling purpose. And the disadvantage we have, of course, complication, additional components are being added. Added inertia because of the storage of the liquid. Leakage concerns, electric short concerns are huge in this aspect. Higher maintenance and higher cost are some of the other factors. Then the last component in my presentation is that of the refrigerated liquid or direct refrigerant. We have two types here. The refrigerated liquid is, we have two different liquids in here. One is the liquid, the refrigerant within the HVAC system. Another one is a heat transfer fluid, which is being transported into that of the battery pack. Whereas we have also another mechanism in which the refrigerant itself is being utilized as a heat transfer fluid, where it will be a cooling fluid. Then again, in this case, the liquid can be utilized as an immersion, or we can use it as a jacket as well. So we have two arrangements in the battery pack itself. So we have two technologies here. One is the GM Chevrolet Volt, as well as that of the Tesla design, which are employing this type of technology. So the advantage here we have is, of course, we'll have uniform battery pack temperature. Depending upon the heat transfer fluid we use, we have higher heat transport capacity. It is a compact design, and we have a precise temperature control. We can control the temperature as per our desire. We have huge flexibility in here. The disadvantage is complication, additional components, added inertia, leakage concerns, higher maintenance, higher cost, higher parasitic power. So these are the major concerns in this aspect. Then further consideration, which I didn't include in my presentation slide, but which are an interest in the research, which I feel that as a researcher, you may further look at. Natural numerical predictions of the heat generation in the battery pack at a varied operation conditions. Then validation of the prediction is one component of it. Numerical and computational investigation of different types of BTMS systems. as far as natural air or conditioned air is concerned, ANSYS can do it well. And there is a tool in ANSYS, and you can use that embedded tool to investigate. But when we are employing the other forms of BTMS, then you may require additional computational tools to further deal with it. So these are some other research areas. Another thing which I didn't present is we have a hybrid BTMS system, which may include that of air and PCM, that of liquid and PCM. So we have recirculation BTMS systems in which the PCM is coupled with that of either air or other liquids. So this is also having wide attention currently. The other issue is in the passive mode of the PCM itself. As I said before, PCM has lower thermal conductivity. So in order to improve the thermal conductivity of the PCM, we can add some nanoparticles. So we have this nano PCM passive BTMS system. And even the PCM itself, we have novel PCMs. Instead of utilizing that of the commercially available PCMs, we can employ different types of novel PCMs where we can design our own customized novel PCM. So we can work in that aspect as well. This is one of the research area. Another issue is beyond the thermal management, how about waste heat recovery? You know, the electric vehicle and hybrid vehicles, they are known for the utilization of recovered energy from the regenerative braking. How about we just associate the amount of heat which is being wasted from the battery to employ it further within the vehicle itself? So waste heat recovery for performance improvement. This is another issue which you can consider as well. So these are the further considerations you might think. So from my side, I have one more activity, and I will copy and paste this. It is a Google Drive, Google form, or it is a Google document. And the question is, we have different types of the BTMS systems, and we have the criteria which I have mentioned previously. So for each type of the BTMS, you just rate the different criteria. Just you rate it from 1 to 10, and you give it value just based on your own perspective. So we will evaluate that of the different types of BTMS based on the given criteria. So again, this is quite subjective. We are not employing a thorough scientific method, but it might give us some highlights, and it will help you also to look at the advantages and disadvantages beyond the one which I presented now. So I think, I don't know if we have more time, we can exercise this. Otherwise, let me see how much time we have.
Sir, time is over, and now it's the question answer session.
All right. Okay. So
yes,
maybe
it is requested to all participants. Please ask your queries you have.
All right. Okay. Thank you very much. Yeah.
Ashish, please unmute all, and if someone asks, then
Mhm.
Participant can unmute themselves. If you have any query, you can. The session is open to all.
Mhm. Probably this is lunchtime, right? Mm. Mhm.
it's lunchtime, sir. I think there is no query from the participant side. So I am very thankful to you, sir, on behalf of NIT Srinagar and on my personal behalf. I am very thankful for so insightful and exhaustive lecture. And it's a lot of information regarding battery management, thermal management, and the architecture of the battery. So it's a very informative lecture, sir.
Yeah. Thank you very much too. Thank you for the organizers and also the participants. Yeah. As I
Sir, one
mentioned,
question, I think one question is there in the chat box. What are the techniques to reduce the heating problems in battery? I think it is already covered, but please, if you want to.
Yeah, I think we have been discussing the techniques. Either we can recirculate a liquid, or we can also blow in air. So we have two types, as I mentioned. One is the passive mode, whereas the second one is forced mode. So I think that was the overall content of the presentation.
Yes, yes.
Yeah.
So thank you, sir, for your valuable time. It was an interactive and informative session. Thank you for enlightening us. Thank you so much, sir, on behalf of NIT Srinagar. We are highly thankful to you, and we are looking forward to hear you again in our upcoming series. Your presence has enriched this session. Thank you, sir.
Okay. Yeah. Thank you very much, everybody. Okay. Have a very good day.
Thank you, sir. Thank you.
Yeah. I wish you success with the rest of your presentations.
Thank you, sir.
Thank you, sir. Thank you.
Okay. Thank you. Yeah.
Okay.